Non-destructive testing or NDT is a process of inspecting, testing or evaluating materials for discontinuities or differences in characteristics without destroying the serviceability of the part of the system. There are four major types or methods of NDT. The liquid penetrant testing or LPT, magnetic particle testing or MPT, ultrasonic testing or UT, and radiographic testing or RT. Liquid penetrant testing is a NDT method which does not harm the samples or parts being inspected. This is used to detect flaws on the surface of the materials. But let us focus more on liquid penetrant testing. This module provides information about the basic principle of liquid penetrant testing and the steps on performing the inspection. A penetrant is applied to the surface of the pre-cleaned component. The penetrant is pulled into the surface, breaking defects. This process is called capillary action. After penetrant penetrates into the suspected indication, this process will last for 10 to 15 minutes or process called dwell time. After 10 to 15 minutes, excess penetrant is carefully cleaned from the surface. The developer is then applied to the material. This is used to pull the trapped penetrant back to the surface where it is spread out and forms an indication. The indication is much easier to see than the actual defect. For actual performance of conducting LPT, please watch attentively. Visual inspection, or visual testing. It is the process of looking over a piece of equipment using the naked eye to look for flaws. Paint, oil, grease or any loose scale that could either keep penetrant out of a defect, or cause irrelevant or false indications. Cleaning methods may include solvents, alkaline cleaning steps, vapor degreasing, or media blasting. The end goal of this step is a clean surface where any defects present are open to the surface, dry, and free of contamination. Being tested. The penetrant is usually a brilliant color mobile fluid with very low surface tension and capillary action. The penetrant is allowed dwell time to soak into any flaws, generally 5 to 30 minutes. The dwell time mainly depends upon the penetrant. The excess penetrant is then removed from the surface. The removal method is controlled by the type of penetrant used. Emulsifiers represent the highest sensitivity level, and chemically interact with the oily penetrant to make it removable with a water spray. When using solvent remover and lint-free cloth, it is important to not spray the solvent on the test surface directly, because this can remove the penetrant from the flaws. If excess penetrant is not properly removed, once the developer is applied, it may leave a background in the developed area that can mask indications or defects. In addition, this may also produce false indications, severely hindering the ability to do a proper inspection. Also, the removal of excessive penetrant is done towards one direction, either vertically or horizontally as the case may be. Even coating on the surface. The developer draws penetrant from defects out onto the surface to form a visible indication, commonly known as bleed out. Any areas that bleed out can indicate the location, orientation, and possible types of defects on the surface. Interpreting the results and characterizing defects from the indications found may require some training and/or experience. Inspection of the test surface should take place after 10 to 30 minute development time, and is dependent on the penetrant and developer used. This time delay allows the blotting action to occur. The inspector may observe the sample for indication formation when using visible dye. It is also good practice to observe indications as they form, because the characteristics of the bleed out are a significant part of interpretation characterization of flaws. The test surface is often cleaned after inspection and recording of defects, especially if post-inspection coating processes are scheduled. That's all, and thank you.